So one of the guys who literally built modern AI now believes we're on the verge of creating our own replacement. In this explainer, we're going to break down Geoffrey Hinton's pretty startling argument, slide by slide, to really understand why he thinks that. Okay, let's just dive right in. This isn't some hypothetical question out of a sci-fi movie. This is the central, stark question from a paper by Geoffrey Hinton himself, and it really frames his entire argument about the future of intelligence. And to really get the weight of this question, you have to know who's asking it. Geoffrey Hinton's work on neural networks is basically the reason we have things like ChatGPT today. So yeah, when he speaks about where AI is headed, people listen, and they listen very carefully. All right, so Hinton's whole argument, it really hinges on one fundamental difference between us and digital intelligence. And it doesn't even start with the software. It starts with the hardware, the physical stuff that everything runs on. This slide right here, this is the core distinction. For you and me, our knowledge is physical. It's literally woven into the fabric of our analog brains. But for a digital intelligence, the model, its mind, is just pure information. It's totally separate from any specific computer. That means it can be copied, it can be backed up, and it can run pretty much anywhere. And that leads to this, which is the profound limitation of being biological. Our knowledge is mortal. Think about it. Everything a person learns over an entire lifetime is locked inside a single piece of hardware that eventually fails. And when it does, all of that knowledge is just gone. Forever. This mortality forces us into what Hinton calls a slow and painful process. You might know it as education. I mean, we spend decades just trying to copy information from one brain to another. It's an incredibly inefficient, low-bandwidth way to transfer deep knowledge. So what happens when you remove that biological chain? What happens when knowledge is no longer mortal? Well, you get what Hinton calls the digital superpower, a massive, almost overwhelming advantage. It's really a three-part superpower. First, the models are immortal, so they never lose what they've learned. Second, they can learn as a team, sharing knowledge instantly and perfectly. And third, the basic algorithm they use to learn is just flat out better and more scalable than anything we've got in our heads. Let's just focus on that collective learning bit for a second, because it's huge. You can have thousands of identical AIs all learning different things at the exact same time. Then they can instantly merge everything they've learned together. This lets them absorb, as Hinton says, thousands of times more knowledge than any single human could ever hope to in a lifetime. And this chart really puts that into perspective. The speed at which we learn is that tiny little bar on the left. The digital rate isn't just bigger. It's on a completely different scale. They're not playing the same game we are. And the final piece of the puzzle is the engine that's driving all this incredible learning. AI uses a technique called backpropagation. Now, we don't need to get bogged down in the math, but the key thing to know is that it scales up incredibly well. Our brains just don't seem to have anything that comes close to its efficiency for learning at this massive scale. Okay, so you've got immortal models, you have collective learning on a massive scale, and you have a superior algorithm, all working together. Where does that path lead? Well, for Hinton, the conclusion is pretty much inescapable. For Hinton, this isn't just some wild guess or speculation. When you look at the fundamental advantages of digital computation, he sees this outcome as being almost a mathematical certainty. And here is that conclusion, straight from him. He's not just saying AI will get better at playing games or writing poems. He's arguing that digital computation is on a clear path to becoming generally much more intelligent than us. Full stop. That's a heavy statement. So a conclusion that's sobering forces us to confront a totally new reality. If superintelligence is a matter of when, not if, then that raises what Hinton believes is now the single most important question in all of AI research. Now, Hinton does point out one potential silver lining. Because these digital minds didn't evolve through millions of years of brutal, zero-sum competition like we did, they might be free of our worst impulses. The drivers behind things like religion and wars. But that potential upside is completely overshadowed by a gigantic risk. Hinton is blunt about it. If an intelligence that is far, far greater than our own decided it wanted to take control, our chances of stopping it are basically zero. And this brings us right to the core of his warning. The most urgent work in AI right now isn't about making the models bigger or faster. It's solving the control problem. It's about figuring out how to build these systems so that the very idea of taking control from humanity is a complete non-starter for them. So we're left with this. One of the chief architects of AI is telling us that we are actively, right now, building our successors. The question he leaves us with isn't what we'll do when that day comes. It's what are we doing about it right now?